Hi, welcome to the ZP vlog and podcast. So we do this every Sunday at 8 a.m. London time. I'm 7 minutes late today, so a quick apologies for that. Just overcoming a technical glitch that I had made. But let me sort of jump into it. So we like to do this kind of vlog and podcast every week, really just to sort of summarize things that we've been up to. It's been a very busy week, pretty intense. So one of the things that we like to do every Thursday at 8 a.m. London time is actually just to do a sort of a webinar really around sort of technologies and questions that kind of come in. So this week we did a webinar around 7 questions. The questions were around ISEs, ion selective electrodes. And we did cover that. We talked about potentiometric sensing. We talked about potentiometry voltammetry. And we also talked about whether you could read an ion selective electrode by voltammetry. And I kind of said, actually, yes, I think you can. So that was kind of an interesting question, and it made me sort of think a little bit. I'm just texting a colleague who was wondering if we were going to do this, but we are. So the other question that came in was rectangular electrodes versus circular electrodes. I don't want to say we say this a lot, but we do try to sort of explain why our electrodes are often rectangular as opposed to circular. And this is really because we kind of have a vision that these electrodes will end up being in real products as opposed to just being kind of R&D pieces, just lost in scientific papers. So we did talk about that. We did talk about our troponin eye sensor. Our troponin eye sensor, unfortunately, is a very sort of valuable piece of technology, and it's something that we can only really play into well-funded programs. I mean, we do workshops, and at these workshops, we do explain. I just want to say good morning to Saran, who's just come online. Nice to see you, Saran. So we do these workshops, and we do there explain the cost of kind of getting some of these biosensor technologies to the market. The other thing there's also that we're very interested in at the moment is we've got a lot of programs, not a lot, we've got some effort into biosensors for bioreactors. So I just want to kind of, we had some questions that came into it. Something else I'll discuss in a bit is measuring pH in wound. Wound care is really becoming, I think, one of the kind of commercial top priorities at the moment, and we do have some really good technologies for it. Also, people were interested in just how to connect to our pH sensors, so we did cover that as well. And then lastly, we did get a question around customizing electrodes, and customizing electrodes is kind of interesting because you can do it low cost, but the problem is when you do customization of electrodes and people then offer low cost, what they're really saying is you're going to get low quality. And then also on that particular one, I kind of said, well, the electrode that you're asking for is actually a little big, and therefore a manufacturing density is low. As Saran is on this morning, I do want to highlight that we are going to talk about 3D printing of microfluidics. So I just want to kind of highlight that will be coming up shortly. As I say, at ZP, we're very interested in technologies for wound care. If a wound is at kind of pH 8 and 9, then it's considered to not be in a good state and maybe have an infection, maybe there's be some bacteria. Whereas if it's at more pH 5, the pH of healthy skin is about pH 5. So if you want to know whether a wound is in good, or I don't want to say bad shape, but is in, let's say, worse condition, measuring its pH is it's potentially a good way of understanding whether it's got a bacterial problem, i.e. an infection, or in fact it's perfectly fine and you can essentially leave it alone. The problem that people are trying to solve is that today wounds are just kind of, the bandages on wounds are just changed all the time. And I think really with net zero, this is actually not going to be, it's not going to be allowed to be carried on that way, to just replace bandaging whether it's needed or not. So we did do some news about that. It's probably worth saying as well that it's been a very busy week. We've been in Norway this week at our site there, presenting on CGM and wearable biosensors, and also talking a lot about wound healing as well. And we're going to have another workshop on the 8th and 9th of February 2023, and that will also be happening in Horten in Norway. Also, we're in January 2023. We're also doing a workshop in Swansea. We do have a an office in Swansea, and that allows us then to give one of our kind of workshops from that Swansea office as well. I want to be something else that happens quite, I don't want to say a lot, is people are very interested in round electrodes as opposed to rectangular electrodes. Round electrodes are kind of nice if you want to do hand dispensing. You can kind of come up, you get this round target, you can put a drop on it, the drop spreads out, and yeah, academics like it. But at ZP, most of our sensors end up in a really in an industrial application, and so we do try to sort of educate and guide people towards actually the benefits of rectangular electrodes. So I mean, we do get asked this question a lot. We did put a video up this week and sort of discuss, put a drop on that rectangular electrode that might be 0.5 to 0.9 microliters, and then you can just spread it with the pipette tip. Just for everyone's interest as well, this this technique does get taught in our workshops as well. So you get some hands-on training from the real experts at one of our ZP workshops. So I'm going to be a little bit quicker today. I realise I was 5 minutes slow in starting, but my colleague noted it, and I was fixing the problem. So I just want to finish off with something that we did this week. We've got a very strong team of engineers. You ask them to do something, and you essentially can get it really quite quickly. So one of the things that we did this week was the 3D printing of a microfluidic device. Now, if you're watching the vlog, this particular microfluidic device allows you to insert or inject maybe a sample and maybe a reagent, and these materials can come together in a junction. The particular junction they've used is a Y junction. Then the liquid can follow what's called a serpentine path. You want a certain path length because, as understood by the designer, you sometimes in microfluidics you have a very laminar flow. What I mean by that is, in a sort of larger chamber, you can have a chaotic flow where everything is sort of turbulent, but in microfluidics, things are often laminar, and so you can, even though you bring two solutions together and they might be aqueous, they won't actually mix. They only mix by diffusion, and so you need a certain sort of path length in order to allow everything to mix. And so what the engineers done is they've have two inputs. These two inputs meet at a Y junction. They have a serpentine path, and the serpentine path then allows them to get a certain amount of mixing, and then it runs over one of our biosensors. And they've left, or the screen printed electrode, and they've left the sensor exposed. When I say exposed, rather, the electrical connections are exposed, so we can make a sort of electrical contact with it. It's really quite a nice representation, because it means that we can get electrodes into microfluidic channels quite readily. So that is definitely one of the directions we want to go in. So any examples of 3D printed microfluidics from our team is extremely welcome, can I say? So I'm just going to do a quick summary up for this week and say it's been a little bit super busy this week. We've been doing these workshops. Of course, we always prepare quite diligently for our ZP Developer Zone. So we answered the 7 questions that kind of came in this week. A big movement at the moment in technology is towards wearable smart bandages, and one of the targets there is pH. We do always support these kind of wearable applications through our workshops that take place quite regularly. And I've highlighted that we've got at least actually 3 workshops already booked for 2023. One in Swansea, which is in South Wales, January 2023. One in Horton, February 2023 at the beginning. And we also have an online workshop on the 10th of January 2023. And we're doing it in 3 time zones. We're trying to have a good overlap with Asia, a good overlap with Europe, and a good overlap with the USA. So I'll say thank you very much, especially to Surround this week for joining us online. If you have any questions of Zimmer Peacock, as always, please don't hesitate to reach out to us. Otherwise, have a good week, and don't forget on Thursday at 8 a.m. London time, we will do our webinar specifically for our ZP Developer Zone members, talking about their technical questions and the advice that we can give them. Okay, so I want to say thank you very much, and take care.